guys. This section is chapter 6. We're starting chapter 6, which is the relationships within triangles. We're going to start with the perpendicular bisectors and bisectors of triangles. So you can go ahead and write your learning target. I can use theorems about perpendicular bisectors, and I can use bisectors of triangles. So the perpendicular bisector, recall that a perpendicular bisector of a line, right, is a segment that splits that it's a line that splits that segment into two equal parts, right? And it also creates a 90-degree angle, okay? So a point is equidistant from two figures when the point is the same distance from each figure. So equidistance is a word that you had to do for your vocabulary, so that just means same distance, okay? So if I have this line here, CP is the perpendicular bisector of AB, right? If I created the segment AC here, that would be the same length as the segment CB, okay? And that's what we're gonna see here as an example. So find each measure right here. So I have, okay, I know that SQ is the perpendicular bisector of RP, okay? So because I have these two tick marks and I have the 90-degree angle, okay? So because that is the perpendicular bisector of RP, then I know that SP here is gonna be congruent to SR, okay? So RS or SR is gonna be equal to the same as SP, which is 6.8. Okay, so it's really straightforward like that, okay? You just have to first identify the perpendicular bisector. Once you identify it, you can find those measurements easily. So let's take a look here. Now I'm looking for EG. So I have EG, okay? I know that this line FH is the perpendicular bisector of EG because you see how this GH is congruent to EH. So because those are congruent, and this is a 90-degree angle, I know that these two are going to be congruent, okay? So in order for me to find EG, which is the total, okay, I just take 9.5 times 2, okay? So that means that EG is going to be equal to 19. All right, let's take a look at this example here. This is same thing, but now we have expressions, okay? We have 3x plus 14 for CD, and then 5x for AD, okay? I know this is a perpendicular bisector, okay, because of the tick marks and the 90-degree angle. So I know that CD is equal to AD. So CD equals AD, okay? So then you substitute. CD is 3x plus 14, and AD is 5x, okay? Then you proceed at solving the equation. So we minus 3x from both sides, and we get 14 equals 2x, divide by 2, and we get x equals 7. Now that's not my answer yet. I found x, which is the measure of AD, right? So AD equals 5x. So AD equals 5 times 7, and AD equals 35. Okay, so that's our final answer here, 35. Okay, so let's take a look at the next one. The next one involves knowing a little bit more about triangles, right? Because notice that these are angles right here, angle measures, and I'm looking for the angle BCD. So angle BCD is this angle right here. So in order to do that, I gotta figure out, okay, I know that this is a right triangle, so this is 90 degrees. So I know that the three angles add to 180, okay? So I just have to make these two expressions plus 90 equals 180, okay? So that would be one way. So 10x minus 5 plus x plus 7 equals 180. Sorry, plus 90 equals 180. Sorry about that. I want to fix this here. So x plus 7 plus 90 equals 180, okay? So now we actually combine like terms, right? So I have 10x with x, and then I have negative 5 plus 7 plus 90. Okay, I have to combine like terms. So here I get 11x, and then negative 5 plus 7, that gives me 2. So this is going to be plus 92 equals 180. Okay, we minus 92 from both sides. 11x equals 88. Sorry about that. 88. I divide by 11 and I get x equals 8. Okay, so that is x, but now I'm looking for the angle BCD. So the measure of angle BCD equals 10x minus 5. So we substitute, we get 10 times 8 minus 5. So that is equal to 75 degrees. Okay, you're gonna have to be solving some of these problems on the assignment. Okay, so that's why I wanted to go over with you. Let's take a look at another example. All right, this should be straightforward as well. So we're gonna use this figure for all these problems, okay? So ZX is the perpendicular bisector. So if ZX is the perpendicular bisector, I can put some markings here, right? And then that's 90-degree angle. YZ is 13.75. So here I have YZ is 13.75, and I'm looking for WZ. See, these two are congruent, right? So YZ equals WZ, which equals 13.75. Okay, so they're just the same. All right, now this is a different example now, a different problem, okay? We're not using the information above to do this. So we have the perpendicular bisector, WZ. So now we have WZ is 4n minus 13, and YZ, okay, is n plus 17. So we know that WZ is equal to YZ. So we substitute WZ is 4n minus 13, and that is equal to YZ, that is n plus 17. Okay, so now we're going to have to move the variables to one side and the numbers to the other. So I'm going to go ahead and rewrite it here. So we have more room, n plus 17. So I'm going to minus n on both sides. So I get 4n minus n gives me 3n minus 13 equals 17. I add 13 to both sides. So I'm going to get 3n equals 30. Divide by 3. N equals 10. Okay, so now the question is not asking for n, it's asking for YZ. So YZ, I have to substitute now. So YZ equals n plus 17. That means that YZ equals 27. All right, now find WX. So now I'm looking for this part right here. WZ WZ is 20.5. WY, so this whole thing here, right, is 14.8. And YZ is 20.5. Okay, so we don't need the WZ or YZ to find that, because if this is the whole thing, WY is 14.8, then, and I want to find half of it, right, I'll just do 14.8 divided by 2, so that equals to 7.4. That's my WX. Okay, now we're looking for the measure of ZWY. So I have ZWY, so I want this angle here, okay? When ZYW is, so this angle here is 10x plus 5, okay? This angle YZW, so that angle here, the full angle here is 4x plus 14, okay? So now we have to remember that the three angles of a triangle equals 180, right? And since these two sides are the same, this is an isosceles triangle, okay? Which means that these angles are the same, okay? So basically what I have to write here as an expression is, let me write it over here, 10x plus 5 plus 10x plus 5 again, right? Plus 4x plus 14 equals 180. Okay, now we're going to combine like terms, the x's with the x's and the numbers with the numbers. So now 10x plus 10x plus 4x, that gives me 24x. 5 plus 5 is 10. 10 plus 14 is 24, equals 180. Okay, so I'm going to move it over here. 24x plus 24 equals 180. So I minus 24 from both sides. 24x equals 180 minus 24. That is 156. And then when I divide by 24, I get x equals 6.5. Okay, but the question is asking for ZWY. So ZWY is one of these angles that has the 10x plus 5. So 10 times 6.5 plus 5, that gives me 65 plus 5, which is 70 degrees. Okay, so that's the measure of that angle. All right, last thing we're gonna do on this set of notes, because you're gonna do number 9 on your own, okay? So this is for you to do, okay? But I'm gonna show you how to do it. We're going to find, we wanna write the equation of the perpendicular bisector, okay, of a segment. So the first thing you wanna do is graph it. Graph the segment. So this is PQ. Okay, now to find the perpendicular bisector, so first we graph it, then we need to find the midpoint of PQ. You can either use the midpoint formula, or here we can see, look, that the middle is going to be right here. Okay, so 1, 1, 2, 3, 1, 1, 2, 3. So that's the middle. So that means the midpoint is 1, comma 2. Now we have to find the slope of the perpendicular bisector. In order to do that, we need to first find the slope of PQ. So slope of PQ. Again, you can use the formula, or you can just count. So 1, 2, 2 down, so that's negative 2 over 1, 2, 3, 4, 5, 6. So that is equal to negative 1/3. Now we know that the slope of the perpendicular bisector, slope of perpendicular bisector has to be opposite reciprocal, right? So opposite reciprocal. Okay, so opposite reciprocal of -1/3 is 3. Now we have to use, okay, the midpoint, which is 1, 2, and the slope of 3 to write the equation of the line. So we can use y equals mx plus b. We're going to substitute x and y. So we have 2 equals m, which is 3, times x, which is 1, plus b. Okay, and then we're going to find b. So this is going to be 2 equals 3 plus b. We minus 3 on both sides. So we get -1 equals b. Once we find b, all we have to do is write y equals mx, 3x, minus 1. Okay, and this is the equation of the perpendicular bisector. Remember, we want to write the equation of the perpendicular bisector. Okay, so I'm going to ask you to do this on your own, okay? And then I want you to just read through this. We're going to be constructing the circumcenter and the incenter of a circle, of a triangle, sorry, in the near future.